Thank you very much for the kind words about me. So, as it has happened for everybody, I also have to say that sort of the time given to me is quite less, but I'll try to see that I finish in that time. Especially, what I would be saying would be quite general because we can't go deep into the subject. And I hope some of you might feel that this is already known to you. I'm not sure, but some of them may be sort of benefited by what I'm trying to tell. Basically, structural steel is the ideal material for structures in areas prone to severe earthquake zones, that is high seismic zones. No doubt it is costly. That is one of the reasons why in India structural steel has not been so popular, but I was glad to see today, which sort of I was not yet aware till recently, that because in my active life I have seen structural steel only being used for industrial structures, warehouses, sheds, etc., not very much in commercial or residential buildings. But today I have realized that structural steel is being used for commercial buildings also and hotels, etc. So I was very pleased for that, and I'm sure this will grow as the time comes because of the advantages of structural steel. And especially like my earlier speaker said, if we can use stainless steel, in certain cases it will be still beneficial. And as I say, it is costlier, but the advantage is like some of the projects where I was involved in my active life, some of the clients said, doesn't matter if it's costly, but we want the factory to come up earlier because we can start production earlier and we can start generating income earlier. So even though it was proved, we had to compare and show them if you do it in RCC, this will be the cost. If you do it in structural steel, this will be the cost. They said, it doesn't matter, do it in structural steel. That is one of the things. Now, I'll start sort of with various type of structures and what will be the things we have to do under seismic conditions. So, main thing for the same loading condition and layout, structural steel is always lighter. I'm sure everybody will agree with that. And hence, the resultant horizontal forces due to seismic forces, which is due to the total load. So, for steel structures, the horizontal forces are less, and that is why it is beneficial for seismic areas only. And I will show some simple sketches to show what is the frame structure. So this is a structure which is the first one, which is one for the light. Oh no, sorry. What I have done? I pressed the wrong button, I think. Now, again, to sort of resist the seismic forces, there are basically two ways of doing it. One is to have bracings, which is economical and which you don't create any moments at any of the joints. They're all virtually vertical and horizontal forces only, and it will be taken up by the boards. It is much simpler connection, much cheaper, and much more firmer structure. So I would always prefer to go in for a braced structure. And only thing is, like, since I have been I always refer back to industrial projects. Many of the chemical plants or hazardous plants, etc., they don't allow the structural engineer to put the bracings because they say that when there is any hazard and the employees have to run out, the bracings like this, for example, people won't be able to run out fast. They will bang against the structure and get injured. So that is where if they allow the bracings, they said, okay, you go, I will allow this type of bracing because there, there is much larger space available in the middle for people to run out. And this is the case normally in the multi-story industrial building, the ground floor. It is very important. Upper stories they may allow. So this is basically two important types. There are some small variations like knee bracing, etc., but which are not ideal solutions, so to say. This is also a typical sort of a frame for a shed type structure, the bracings which are shown. And as I always say, whether there is seismic load or even whether there is very small wind load, you should always have bracings in a structure because the structure as a whole building becomes quite rigid. It helps right from the erection stage. The building is always very rigid and very firm, and there is not much of swaying, etc. So as I say, it is always preferable to go in for cross bracings. Because cross bracing, whenever there is a horizontal force either due to earthquake or due to wind, one of the members only in action, it is in tension, the other one is not playing any role. While in an A-type bracing, it has to be in compression. So naturally steel is not ideal for compression. So it is you have to make a stronger member, and then it is costlier. So whether bracings can, as I told already earlier, you have to decide whether bracing is allowed or not, and if it's not allowed, then you have to go in for moment connections. So I have shown some typical moment connections here. Like see, here this is for taking the shear, while the connection that this one they are for resisting the moment. This is, I would say, a fully welded moment connection. This is also fully welded. All these are fully welded. Oh, I'm sorry. Oh, I don't know what's happened. Can I not go back? No. Moment connections can be of so many types. I have shown just some of them to show, like for example, in some cases you make it still stronger by putting this as it is optional, sometimes it is necessary, etc. But these are various types, so to say. Now, going back to sort of a frame structure, basically we talk about beams and columns. So when you talk about moment connections, the beam is designed, the column is also designed. But because where you want to have a column which is resisting the moment by itself also, because not only the connections at the joints, but also the columns as such have to resist moment. So I just mentioned a few words about what sort of sections we should use for columns. Now, basically, at least to the best of my knowledge, I don't know if I am wrong, India IS sections, we have tables for all types of sections, but what is being rolled by the rolling mill is only I sections, which is very uneconomical for columns. And we have to go in for H sections. I heard that some company is making the H section, but not full requirement of the country, so we have to import those sections. Instead of that, there are various alternatives which you can go in for using the sections which are available in India. I will show you that. Depending on the type of structure, we can use double angle or double channel, converting them into a box by welding, or a plus shape. I will show all of them, and then outlet which is better. See, I have shown the various combinations possible. See, the first one is using two angles and making it into a box. Then these are two channels made into a box. Then these are an I-beam, then using plates at the end to make into a box. This is also quite expensive. These are using 4 plates when you have to go in for very large sections. I remember I used such sections for power station columns only. Now this is also a typical I section with channels or just at the edges, angles, etc. And this is one section. When I first use it, this is actually an I section. The another I section is cut into 2 and welded to that, so it forms a plus shape. This is very ideal for very high loaded structures and where there is moment also. I remember when I first used this, many of my colleagues are telling, how can you do this, it's not possible, this will bend, distort, etc. But nothing like that happened. And maybe I was the first person in the office at that time and I had no reference material also, but still I took the sort of guts to use it, and it succeeded. In a project, it was very useful because the steel work, the weight was quite less for the capacity. You see, it was a very highly loaded structure. Because as I said, in now such plus sections, especially we use two sections, same property like ISMB 400 or ISMB 300, whatever is required. You get X and Y axis, same moments of inertia, virtually. There is slight difference because you are cutting it fully. So, and now these are the things which I would recommend. But there are other things which we have been used to using in structural steel, especially in earlier days when we were only using riveting and bolted structures. With the advent of welding, those type of sections, irrespective of whether you use it for earthquake or anything, I would recommend that we should not use. I will just show them. Like for example, a channel, either placed like this close to one another or away, or using angles like this. See, the angle like this is better than this for resisting compression. But if you use the same material and make it into a box, it is much more stronger than its properties like this. I'm sure if you check it, if you have not done it, you can check it and you see the properties. you will find that the box section is much more economical and less material is also used, because see, if you see here, you have to use a plate to join them. You have to use a bolt or again put another plate inside. Here also you have to put some packing material to maintain the spacing. Here also you have to put some packing material, and normally this is also not recommended because you cannot paint the inside. This you should never use like this unless you weld them together. But the same thing, if you use it as a box, you are using the same material and with much more strength. And I'm just touching upon tall, narrow light structures, like transmission line towers or independent towers for lights, or for I have used it in the nuclear sort of heavy water plants, etc., for putting their sort of certain instruments at the certain top. So for all such structures, normally wind load governs. So I'm just mentioning it here because you won't need any seismic factors here, because wind will govern only. Now again I'm coming back to moment section and showing some more sort of fully bolted. These are all typical bolted connections. Even in structures where no bracing is allowed for any reason, as I am just coming back to that topic, moment connections have to be provided at all joints, columns and beams where moments occur. So this could be, as I have shown here, fully bolted, or as I have shown in the earlier sketch, it could be a combination or only welded also. These again are typical sort of moment connections, again of different types, etc. When you are connecting on the web, how to do the moment connection, which is very rare, because normally, see again this is showing an edge section. In India, if you use an I section, it will be very weak on that axis, so the column itself will not be enough to take the moment. So such a joint is very rarely used, especially this type of joint only. But this is possible, where this is totally bolted except the plate which is joined to the column by welding. Now this is also again, see all those connections which are shown are typical, where you have only sort of a column and a beam, while this is a typical connection in the middle of a structure where you have got beams on both sides, column going through, maybe you will have beams in this side also. So they are typical connection. Again, these are all sort of, there are so many variations possible, it all depends upon the moment, how much resistance, etc. And these are fully welded, and as my personal opinion, never going for fully welded, especially site welded, because the quality of work will not be guaranteed, it will not be good, especially in Indian conditions I have seen. The welding at site is not of a good quality. So you should always go in for some assembly bolts and preferably bolted connection, or a welding where the welding is, there are so many types of welding possible, where you should avoid overhead welding, etc., so that the welding is made easier and more comfortable welder, and you don't find some sort of wrong things done in the welding. So like these are typical recommended joints like this. See, because you leave some gap, so you can do this sealing run also well. This is a typical, again only fully welded. Again, see, a lot of factors come into the picture like ductility, etc. only. Now then I go in for these type of structures, what type of structures we should use, and what about the moment connection there. We had to go in for a uniform section for the column and for the rafter, because we couldn't do a design with a varying section. Nowadays it is possible, and even I remember some years back where I was working for a company abroad which was using prefabricated structures. We had totally tapered sections for column and multi-tapered, sort of varying section in the rafter also. That's why, as I say, it is always economical and better looking structure to use portal frames than using trusses. And for such tapered I sections, the unique connection can be provided at the knee joint of the column, which I will show next, and the rafter. So normally you go in very bulky connections of the portal frame knee joints. But I have seen and used it in, as I said, a prefabricated company, a bolted connection at the knee. After all, what is moment? As one of my sort of seniors used to say in my earlier days, ultimately it's a couple. So the same moment can be converted into shear forces which will be shared by all the bolts, depending upon the moment that will be shared by the bolts, and that was a very convenient connection for site erection also. No welding was involved, and the rafter and the column used to be just assembled with a slight difference of half a web thickness. because it was off the center, and we used to do the work very fast at site. I will just give a reference because I am not able to get a photo of that, but I will just show you a symbolic way of how it was done. See this, we had a totally bolted connection. The rafter was brought loose, the column was brought loose, and it was assembled at site. And this had sort of a stiffener here, and here the column I section flange was cut on this portion, and the rafter had that piece welded to it. So I am not able to get a clear connection, but I hope you will understand that. But this connection was very convenient, and our company I think had a patented right for that, because I have not seen that thing anywhere else. I have tried to see in any portal frame in India or even abroad, but I don't know if any of my friends here have seen such a connection. But I don't know why people don't use it, even if it is patented or not. You can design a connection like this, and it was standardized. We had about 10 or 12 standard pieces. So within span range, it was used for every, up to this much span, used this standard plate. So the workshop had those plates, stored such connections, and the drawing department used to recommend in the drawing for each type of loading that sort of plate. It was very convenient connection. No welding was involved at the site. Totally bolted connection at the knee. These are, as I said, I've just shown the standard connections for at a portal frame. One of these, we think, having a very bulky look, and I always feel that these look very dirty. And it involves a lot of site work. These are other typical connections, totally welded, partly bolted, then welding at site. This is a typical without tapering section, this with tapering section. But these are all very cumbersome work at site. You are not sure of the quality. Then similarly for such portal frames, again, because normally I don't find such things being used, and people criticize these light purlins in these prefabricated structures, because I know some of my friends who have come here who are working for prefabricated structures could sort of throw more light on that, because many engineers say that this should satisfy IS 800, but prefabricated buildings don't conform to IS 800. They are all designed to some other standard, which in India I don't think we still have developed a standard for that, but abroad in USA and in UK and Europe they have standards for that, and maybe they have some limitations, but it is very light and very cheap. I remember we used to do prefabricated structures, portal frames for standard buildings without any special load within 10 kilogram per square meter. If we did more, then my estimating department would say that we won't get the job. To that extent, and people in India, my friends would never believe that we were able to do structures for 10 kilograms per square meter. So here, to make it very economical, normally when you analyze the portal frame, when there is reversal of stress, the bottom flange gets overstressed at some places, and that is only in certain loading conditions. Now just for that, we have to go in for a higher section for the I-beam, for a higher bottom flange. While if you connect the purlin to the bottom flange by such a simple connection at certain intervals depending upon the unsupported length required for the bottom flange, then the section of the portal frame, the bottom flange, was very small and much economical, and the extra money spent on putting such restraints from the purlin was making the purlin span also slightly less, and also very good restraint provided to the bottom flange. But I don't see much of this being used here. Even now I don't know why. Maybe if I am wrong, please let me know. And now I have just talked about all these other things, but one of the main things which is the property of steel, and for which it is recommended for earthquake resistant structures, is the ductility property, which actually is an advantage, but nowadays after research it is found that it is also a disadvantage. Steel being ductile, deflections are permitted in structures. That means you are allowing some movement. So for example, in concrete you won't allow that much movement. So these forces do not result in cracks in steel work, which again I have to correct, because they do crack, but only in extreme conditions where the design load has not been correct. In the 1990s, 1980s, some steel structures in Japan and then in Mexico, etc. Till that time it was believed that no steel structure will fail in earthquake. But those were the structures in those countries which failed, and failed very badly in earthquake. And then they found the reason for that, etc. Again, that is, so we won't go very deep into it, but just for information, that property of steel has also now, that is why they are going in for certain type of connections which resist such loads also. While in RCC, normally, I am not saying that all RC structures, but quite often you will find, because I went around the structures in Ahmedabad after the earthquake, you will invariably find some cracks at certain places. Building would not have collapsed or even got damaged, but definitely it would have cracked. While in steel, no doubt I didn't have any opportunity to go to see any steel structure because there was no case of any steel structure which was damaged by the earthquake. That's why they said this does not mean that steel structures will never fail. They do happen. And I already talked about that. And now again, ductility is another property which is again a disadvantage, as they say, for bolted joints, because steel being ductile, the connections will stretch, the connection might get loose, etc. And we don't use lock nuts in all connections, we use lock nuts only in anchor bolts. So sometimes the connections get loose, but if you are sure of the forces and they are very high forces, you can go in for high strength friction grip bolts or high tensile bolts, and some very important connections you can even go in for lock nuts, so that property of steel, which is a disadvantage, you can sort of reduce the inconvenience due to that. That's all.